With the launch of the James Webb Space Telescope on Christmas Day 2021, cosmology experienced a seismic upheaval. With its remarkably keen, high-resolution infrared eyes, this sophisticated telescope has transformed our understanding of the universe since it was deployed. With the use of his keen, unblemished, and exquisite observations of the early cosmos, James Webb has been able to provide light on the development of stars, galaxies, and planetary systems, including our own solar system. But James Webb's abilities have exceeded all expectations. Although the telescope revealed an incredible number of galaxies, some of which defy conventional understanding, astronomers had expected to find only an unlimited number of them. These early galaxies that Webb found put our present cosmological models to the test, casting doubt on accepted notions about the universe's origins. Our assumptions are put to the test as we go farther into the far universe. If we travel back in time, we should see a steady decline in the number of massive galaxies, but James Webb's findings show us otherwise. There are a surprising number of unexpected galaxies, some of which are even older than the universe itself. We are essentially asking the universe questions about its early years and how it changed into its current state by examining these old galaxies. With its spectroscopic capabilities, the James Webb Space Telescope pushes the limits of human knowledge and may change our perception of cosmic history by enabling us to test our current models of the cosmos. Beyond its capacity to photograph amazing cosmic occurrences, James Webb is significant because it is rewriting the story of our cosmic origins. By revealing galaxies that date back billions of years, initiatives like WebSeers and the Cosmic Evolution Early Release Science Survey are shattering our assumptions and enhancing our understanding of the universe. Maisie's galaxy, which bears the name of the daughter of researcher Stephen Finkelstein, is one amazing finding. This galaxy, which is 13 billion years old, surprised scientists with its brilliance and color. Its existence shows that our universe is far richer and more complicated than previously thought, challenging our basic theories about the early universe. The James Webb Space Telescope's use of the infrared wavelength accounts for its extraordinary ability to detect very distant galaxies. Using this wavelength is essential for studying galaxies that have greatly receded as a result of the universe's expansion. Although several of these distant galaxies had previously been discovered by the Hubble Space Telescope, which mostly observes light in the optical range, its observation was restricted. This restriction resulted from the fact that galaxies' light shifts toward longer, redder wavelengths as they get farther away from us, a process known as redshift. As a result, they become less visible in optical light and must be observed in the infrared. Hubble's equipment struggled to identify even a handful of these far-off galaxies. But these accomplishments were quickly surpassed by the James Webb Space Telescope. After only a few days of starting its scientific operations, it discovered a multiplicity of galaxies that were significantly farther away than previously thought. Rather than discussing these galaxies' distance, scientists frequently highlight their age. This method was developed in response to the difficulty that the expanding cosmos poses to conventional distance measurements. Take Maisie's galaxy, which is estimated to be 13 billion years old, as an example. Even though it took 13 billion years for the light from this galaxy to reach us, it is currently far further distant than its age would imply due to the universe's continuous expansion. By examining spectral lines, the near-infrared spectrograph on the James Webb Telescope helps determine ages with greater accuracy. Astronomers may calculate the galaxy's real redshift, which indicates its age and distance, using these lines. After photometric observations resulted to an initial redshift estimate of 11.8, spectroscopic investigation showed a redshift of 11.4, putting it in the group of the 4 oldest galaxies verified by spectroscopy. These findings contradict past cosmological theories by indicating that galactic creation most likely began sooner and progressed more quickly than previously believed. The discovery of galaxies only tens of millions of years after the Big Bang suggests that huge galaxies formed more quickly than previously thought. This has important ramifications for how we think about dark matter and how early universe structures arise. Although these results do not refute the viability of popular cosmological models, they do highlight the need for more research and development. Our view of cosmic development has changed as a result of James Webb's findings, which have shown a universe that is far richer and more intricate than previously thought. Scientists hope that more discoveries made with this groundbreaking telescope will expand our understanding of the universe's formation and evolution. Because the majority of a galaxy's luminosity comes from its component stars, the brightness of a galaxy is closely related to its mass. Astronomers can calculate the galaxy's total mass by presuming a particular average brightness and mass for each star. Astronomers can better comprehend the galaxy's origin and evolutionary history by using this mass-to-light ratio, which offers information on the types and distribution of stars within the galaxy. A galaxy's total mass can be roughly estimated by astronomers, but scientists' current understanding of the universe is largely based on modeling that suggests galaxies could not have grown to such vast sizes in the comparatively short time since its creation. Pomona College assistant professor of astronomy Juno compared this disparity to walking into a kindergarten classroom with a teenager. Until recently, the majority of galaxies were divided into two primary groups: ellipticals, which are smooth, spherical masses of light, and spirals, which are disk-like structures with spiral arms of gas and dust. But up until now, astronomers had thought that early universe galaxies wouldn't have the organized classification that exists in galaxies today. These presumptions were contested by the James Webb Space Telescope's observations. It found several early galaxies that are remarkably brilliant and structured, similar to galaxies seen in the nearby universe. Because the appearance of such huge galaxies in the early universe defies previous predictions, astrophysicists are questioning the age of the universe itself in light of this surprising amount of structure and luminosity. According to one researcher, the cosmos might be around 26.7 billion years old, roughly twice as ancient as previously thought. However, scientists are still divided on this concept, and no agreement has been reached. There are a number of possible explanations for the gap between observational data and current theories, including the influence of dark matter in the early universe and unidentified mechanisms that affect galaxy formation. Scientists realized that the early universe differed greatly from the world we see today even before the James Webb Space Telescope was developed. Galaxies were mostly made of hydrogen and helium during this era. They were molded by dark matter and supported enormous, short-lived stars. The early universe's chemical makeup was different from that of the modern universe due to the absence of heavy elements. In addition, the older stars, known as population 3 stars, were very different from the stars of today. Because these early stars lacked heavy components and were bigger, hotter, and bluer, they released more ionizing radiation. While no direct observations of population 3 stars have been made, scientists believe that the James Webb Space Telescope may be able to identify these elusive celestial objects, providing important new information about the early cosmos. The James Webb Space Telescope is essentially meant to transform our knowledge of the early universe. Through providing a window into the distant history of the universe and illuminating the fundamental processes that impacted its evolution, the intriguing data it has acquired takes us closer to discovering the mysterious first stars of the cosmos. Although talking about history that dates back billions of years may seem abstract at first, it is important to comprehend the cosmos from our current point of view. Thanks to its exceptional powers, the James Webb Space Telescope is revealing hitherto unseen elements of the universe and offering previously unattainable insights. Gaining a deeper understanding of the origins and evolution of celestial bodies, such as our own Milky Way galaxy, is vital. Since astronomy works on such large timescales, it is not possible to directly observe things like galaxies during the course of their lifetimes. Similar to newborn photos of the Milky Way, astronomers must examine far-off and ancient counterparts in order to analyze the evolution of galaxies. This project is essential to understanding the complex mechanisms that underlie the creation and development of galaxies and provides important new understandings of our cosmic origins. Furthermore, the search for extraterrestrial life has taken an interesting turn after NASA revealed that 17 identified exoplanets may have subterranean oceans hidden beneath massive ice sheets. These worlds, which resemble Jupiter's cold moons, offer hope for finding biosignatures, chemical indicators of life. Subsurface oceans may be sustained by internal heating mechanisms driven by radioactive decay and tidal forces from host stars, despite their cold surface temperatures and lower density than Earth. Similar to ice volcanoes, cryovolcanic eruptions may also be a sign of geological activity and possible life habitats. In a stunning discovery, researchers have unveiled the dynamics of Mars' atmosphere, exposing a brief occurrence in which part of the planet's atmosphere was briefly swept into space. NASA's Mars Atmosphere and Volatile Evolution Orbiter witnessed this occurrence, which highlights the dynamic interaction between Mars and the solar wind and provides never-before-seen information about how the Martian atmosphere reacts to solar activity. These findings have long-reaching consequences that go far beyond simple scientific curiosity. They affect our comprehension of planetary systems, habitability, and the larger forces producing the universe. Every new discovery we make as we explore the cosmos contributes to our efforts to solve life's mysteries, dispel myths, and broaden our understanding of the universe. The unusual occurrence that the MAVEN satellite just witnessed on Mars is a noteworthy development in the history of Martian atmospheric dynamics. This unusual event, the first of its sort in almost 10 years of MAVEN's operation, occurred as a fast-moving solar wind zone passed its slower-moving counterpart, essentially removing material from the Martian atmosphere. On December 25, 2022, the resulting sparse zone arrived on Mars, giving scientists a rare chance to see the planet's atmosphere develop like it would have if it were orbiting a less chaotic star. MAVEN project leader Jasper Halikas called this unexpected incident a Christmas present from nature, and it is an ideal scientific example. Try something. It allows scientists to investigate the effects of intense solar outbursts and their absence on Mars' atmosphere, providing important new information about the planet's evolution. These discoveries also provide important information to improve models of planetary atmospheres outside of our solar system, which has wider ramifications for our knowledge of Earth-like planets and their interactions with their host stars. Halikas and his colleagues completed a thorough analysis that provides a precise comprehension of the observable occurrences while also shedding light on the underlying physics driving Mars's atmospheric dynamics. MAVEN team member Skylar Shaver underlined the need of deciphering the complex dynamics at work and learning more about the underlying physics. Mars's atmosphere steadily reverted to its initial condition following the passing of the exhausted solar whirlwind, like a jelly plate settling after agitation. Even while similar occurrences have happened before, the availability of orbiting spacecraft like MAVEN offers never-before-seen opportunity to investigate these phenomena in great detail, improving our knowledge of planetary atmospheres and how they react to solar activity. Such intense solar occurrences may have been widespread throughout the early stages of Mars's formation, as suggested by this fleeting event, which also provides intriguing peeks into the planet's early origins. These discoveries highlight the dynamic character of Mars's atmosphere and its significant ramifications for the habitability and geological past of the planet. As solar activity near its maximum, astronomers predict that several comparable catastrophes may occur in the upcoming years. More information regarding the complexities of Martian atmospheric dynamics and their significance for planetary evolution should become available as scientists continue to track and examine data from MAVEN and other missions. In other news, NASA has announced that problems with the Hubble Space Telescope have been successfully resolved. This comes after a string of malfunctions with one of the telescope's gyroscopes. Notwithstanding these difficulties, the ancient telescope, which has been studying the universe for more than 30 years, remains an essential instrument in our effort to solve the secrets of the cosmos. Hubble's return to operation confirms its lasting legacy as a pillar of astronomical research, supporting the efforts of new observatories and guaranteeing future breakthroughs in the field of deep space exploration.